Welcome to Regis Algebra 1. This is Lesson 9A. It will be covering in your book 4.7, which is a review of Chapter 4. And you will have, actually your test on Wednesday will be on Chapter 3, but this will cover review of Chapter 4, 5.1, and 5.2. Let me talk to you about the concepts first in 5.1, 5.2. Then I'll go over the problems in 4.7 if you need that review. Also, we had talked in class about 2.8, the word problems, 2 through 14 even. I went over a couple of those with you, but the answers to 2.8, 2 through 14 even, I did cover on the end of tape Lesson 8B. So check those out to check all those answers. Okay. So I already did give you those on the end of that last tape. All right. So let's talk about the concepts first. When we have something like 5z minus 6z cubed plus 4z squared minus 11. This is called a polynomial. It has 1, 2, 3, 4 terms in it because a term will be separated by a plus or a minus sign from the other terms. So there's a minus sign, a plus sign, and a minus sign separating out these 4 terms. And a term will have things that are going to be a polynomial will have things that are multiplied, added, or subtracted. It will have powers of variables. What it will not have is division, no division by a variable, okay, and no absolute value of a variable with a variable in it. Okay, so those things will not allow us to be talking about polynomials by definition. But when we do have polynomial like this, we can put this in either ascending order or descending order. And what we're talking about is the powers. So we just want to look at our powers. When you go in ascending order, the constant will come first. So if I'm putting this in ascending order, then I'll have the single x term or the z term, whatever, and then the squared, and then the cubed, and then we'll go up in order. So notice in my constant, I have a negative 11 or minus 11. So I cannot lose that negative there. So it's in ascending order, I'd have negative 11, then I'd have this term to the single power, so that would be plus 5z. We're looking above here. Because there's no negative sign in front of it. Then I want the square term next, plus 4z squared. And then I want the cube term, minus 6z cubed. So no real trick here. The constant first, then the first power, the second power, the third power. If you do not have, if one of those are missing, that's all right. Let's say I didn't have a second power, I just skip over it and do the third power next. Do not lose your signs. That's the big trick. So what if I were to do this in descending order? That's ascending order. Descending order, I'd start with the highest power, which is my negative 6, z cubed. Then my next highest power, so my square power. Then to the single power. And then the constant. So my constant would be last. So I have the third power, the second power, the first power, and then my constant. And that's really all there is to 5.1. Problems 6 through 12 are review, but let me just give you answers for those that are not at the end of your book. So these are the answers to the even problems on 5.1. Now let's talk about the concepts on 5.2. I've already covered a little bit of this, what does not constitute a polynomial. So let's look at our examples together. We name a polynomial by the number of terms. So we name a polynomial by the number of terms and the highest term. Okay, number of terms is in our example above where we had our z's. We had 4 terms, and I showed you how that worked. And so that would be a quadratic. I don't care that you talk about, I care that you would know that it's a monomial if it has 1 term, a binomial if it has 2 terms, binomial, trinomial if it has 3 terms. Anything above that, I don't care. You can just call it a polynomial. The highest term is taken from the highest exponential value, the highest exponent that I see. Let's see, there's another aspect to that, but I'm not sure you're getting into it in Algebra 1. It doesn't look like it right now, at least. Okay, so highest exponent. So let's say I have 5x cubed minus 4x plus 1. Is that a polynomial? Yes, it is, because I'm not looking at division by a variable or absolute value by a variable. So all of these are legitimate terms. We have 1, 2, 3 terms, so that would make this a trinomial, and our highest term would talk about the degree. The degree of the polynomial is the same as the highest exponential value. So it's a 3rd degree trinomial. If we have something like 3x and we say, is that a polynomial? And the answer is yes, because this is perfectly legitimate. There's only 1 term, so it's a monomial, and it's to the 1st degree. Because the exponent, if there's nothing written there, but you do have the variable written, that's to the 1st degree. Okay? So this would be a 1st degree monomial. The next example says 3 over x. That is not a polynomial because we are dividing by a variable. I'm sorry, divided by a variable. The next one, we have an absolute value with a variable inside. This is not a polynomial. Okay, so now we can talk about each term. Let's go to the next page. If you have something like 5x to the 4th minus 7x to the 3rd plus x squared minus x plus 8. Okay. First off, we have 1, 2, 3, 4, 5. This is a polynomial with 5 terms, and the highest term is 4. So this is a 4th degree. But we could also talk about the degree of each. So this would be 4th because the exponent is of each term. Because the exponent's 4, this term would be 3rd degree because the exponent is 3. This would have a 2nd degree because the exponent is 2. Okay, the next term here is, it would be, we don't write the 1 up there, but it would be like having a 1 up there when you just have the variable, and so that would be a 1st degree term, and the constant is always a 0 degree term. Okay. the coefficients, so that's my degree, the coefficients are the number that's ahead in the front. So this would be a positive 5 for the coefficient of my first term. The coefficient of my second term would be a negative 7. The coefficient of my third term, this is the same as having a 1 there. And the coefficient of the fourth term, this is the same as having a negative 1 there. And the coefficient of the fifth term is just the 8. Okay, so let's see. I think I've covered pretty much everything you care about there, and you have been asked only to go through 35. I don't care that you know the section 30 problems 37 through 46. Let's see. They're just asking you to do more reordering on 47 through 56, and it looks like just some review. Okay, so I haven't asked you to do anything past number 35, and all those answers are in the back. So, next thing we want to talk about then is the review section 4.7. Even though you don't have the answers, this is the chapter test on page 162. Everything looks straightforward to me, and so only come if you have questions on them until you get to number 8. Number 8 says 2, 4c minus 7 equals 8c plus 14. And if we're solving that, we would distribute. We would get 8c minus 14 equals 8c plus 14. If I, again, move this to the other side, I would subtract out, and 8c minus 8c leaves me with no variable. So then I get negative 14 equals 14. When does negative 14 equal 14? The answer is never. So there is no solution to that equation. That would be number 8. Number 9 has a similar idea. These are kind of some of those exceptions. 6x plus 33 plus 5x equals 11 times x plus 3. So we would add these. We get 11x plus 33. We would distribute on the right side. We get 11x plus 33. Now, I could either just stop right there because 11x plus 33 always equals 11x plus 33, or I can go ahead and move it till I only have numbers, subtracting 11x from both sides. 11x minus 11x makes my variable drop out, and I get 33 equals 33. When does 33 equal 33? Always. And so any value you would plug in for x would make this equation true. Okay. If we're looking at number 16, again, I'm just trying to pick on some of the ones that might be a little more complicated to you. It says solve for x. 3x plus 12y equals 57. And recall that this is the one I'm solving for, so I won't need to take this term to the other side. So I get 3x equals 57 minus 12y, and then I would want to divide by 3. So that means I'm going to divide both terms by 3. So I simplify by, remember, dividing that. That goes in one time in 27, that'd be 19 minus 12 divided by 3 is 4y, and that would be my answer. So a little bit odd because I'm not getting a number per se, I'm getting an expression on the right-hand side with a variable in it. So don't let that throw you. For 17, you're given a formula. volume equals 1/3. He uses a P for pi, R for radius, H for height, and he gives you the value for P, he gives you the value for R, and he gives you the value for H. So you would simply plug in those values for each. 1/3 pi is 3.14. The radius is 4, but don't forget to square it, and that has to be done before you do the rest of the multiplication, and the height is 10. So you do the square, multiply everything else, divide, and you should get a good answer there. Let's look at those word problems, 18, 19, and 20, very quickly and deliberately, however. Okay, we read the problem, and then we identify what we've been given. It says a bricklayer's assistant starts building a wall laying 50 bricks per hour. So the rate of the assistants is 50 bricks per hour. The rate of the master bricklayer is 80 bricks per hour. And he joins 2 hours later. So this is all the information I'm given. And so it's good to just kind of write out your information. Now, it says A, let X be the number of hours since the assistant started laying the bricks. Okay? X equals the hours for the assistant. In terms of X, how many hours has the master been laying? So we want to write an expression with an X in it for the hours of the master. Well, he is 2 hours less because he comes in 2 hours later. So this is A. B says, write an expression for the number of bricks the assistant has laid and the number of bricks the master has laid. So for the assistant, the number of bricks is going to be how much he does per hour. So he does 50 per hour times the number of hours that he's laying the bricks. The master then would be what? The number of bricks per hour times how many hours he lays bricks. Okay? See how he steps you through the logic? He does this very well, actually, because a lot of books only give you the problem and they don't step you through. So write an equation stating that the assistant and the master have laid the same number of bricks. Well, if they are laying the same number of bricks, now recall this, what I just did here, you might even want to write it down, is this has to do with the number of bricks. Okay. So if you have the assistant equals the master for number of bricks, you would have the number of bricks for the assistant equals the number of bricks for the master, just like that. Then it says, that's the equation, how long has each one worked when they have laid the same number of bricks? So X is the hours, right? So I would have to solve for X to get the answer to the second part of C. So to solve for X, you're going to go ahead and distribute. You'll get 50X equals 80X minus 160. You'll get negative 30X equals negative 160. And you're going to go ahead and divide that. So doing that division, of course, I had a negative divided by negative, which is a positive. Cancel out my zeros. I'm going to get 5 1/3 hours. It says how long has each one worked? Well, if that 5 1/3 hours is X, so that's the assistant, right? And so how long has the master been working? It would be 2 hours less, or 3 1/3 hours. And finally, D. Well, you could do D a couple different ways. It says they must lay a total of 1,000 bricks. Will they finish before the assistant has worked 8 hours? Okay, so you could just do this purely algebraically. The assistant's bricks plus the master's bricks has to, right, You might not be comfortable, but it has to equal, we'll do an equal, has to equal at least 1,000. Okay, so if I plug in how many is the assistant bricks, that would be 50 times x. Okay, and I plug in the masters, 80 times x minus 2. Okay, and I could solve for x. That would be the first way I could do it. This is choice 1. Okay, and decide if that is less than or greater than 8 hours. Or choice 2, I could simply use this without making an equation, plug in 8 there, plug in 8 minus 2 or 6 there, and see if I come up with 1,000 bricks or less. Okay, so I want you to look at 19 and 20. Think of the idea that he is walking you step by step through the problem. Be sure to label things, be sure to identify what's been given, and we can review those two in class.